Performance testing is a non-functional testing technique used to determine how an application performs under various conditions, including load, stress, and varying usage scenarios. It ensures that the application is responsive, stable, and scalable under expected and peak conditions, identifying performance bottlenecks before deployment. Key aspects of performance testing. Objective: to validate the speed, scalability, and stability of the application under both normal and peak load conditions. Scope: involves testing various aspects such as load, stress, endurance, spike, volume, and scalability of the system. Focus: measures response time, throughput, resource utilization, and reliability under different workloads. Types of performance testing. Load testing simulates expected user loads to measure how the system handles normal and peak traffic. It helps identify the maximum operating capacity and any performance degradation. Stress testing tests the application under extreme workloads to determine its breaking point. This helps in understanding how the system behaves under high stress and whether it can recover gracefully. Endurance (SOAK) testing evaluates the system's stability and performance over an extended period under a sustained load to check for memory leaks, degradation, or other long-term issues. Spike testing tests the system's performance by suddenly increasing the number of users or transactions to see how it handles a sharp spike in load. Volume testing assesses the application's ability to handle large volumes of data in the database and evaluates system behavior under heavy data loads. Scalability testing determines how well the application scales with an increasing load and whether it can handle future growth efficiently. Performance testing workflow. Requirement analysis: define performance objectives, including load conditions, response time, and resource usage metrics. Test planning: develop a test strategy, including selecting appropriate tools, setting up the test environment, and identifying critical scenarios. Test case design: create test scripts that simulate real user behavior, including login, navigation, and specific workflows. Test environment setup: set up an environment that closely mirrors production, including hardware, software, network configurations, and data. Test execution: run performance tests and monitor application behavior, recording metrics such as response times, error rates, and resource utilization. Analyze results: analyze performance data to identify bottlenecks, failures, and areas for optimization. Tuning and optimization: make necessary adjustments to the application, infrastructure, or configuration based on test results. Retesting: rerun tests to validate improvements and ensure performance meets the required standards. Tools for performance testing. JMeter, a popular open-source tool for load testing web applications, APIs, and other services. Gatling, a tool focused on high-load scenarios, offering powerful scripting capabilities with Scala. LoadRunner, a comprehensive enterprise tool that simulates virtual users for a variety of applications. Apache Bench, a simple tool for basic HTTP load testing, great for quick checks. Locust, a Python-based tool that uses user-defined scripts to simulate user behavior and test application performance. K6, a modern load testing tool for developers with strong scripting capabilities, focused on speed and performance testing of APIs. Best practices for performance testing. Define clear metrics, establish performance metrics, including response time, throughput, error rates, and acceptable levels of resource usage. Simulate realistic scenarios, design test scenarios that mimic actual user behavior to get accurate performance insights. Monitor system resources, track CPU, memory, disk I/O, and network usage during testing to identify potential bottlenecks. Incremental load testing start with a small load and gradually increase to understand the application's performance limits. Analyze bottlenecks. Use performance profiling tools to pinpoint the exact code, query, or component causing delays. Automate performance tests. Integrate performance testing into CI/CD pipelines to detect issues early in the development cycle. Review and optimize regularly. Continuously review test results and optimize code, configurations, and infrastructure. Example of load testing using JMeter. Here's an example of setting up a basic load test for a web application using Apache JMeter. Test plan setup. Create a new test plan and name it, example website load test. Add a thread group, users thread group, to simulate concurrent users. Set the number of threads, users, ramp up period, time to start all users, and loop count, number of test repetitions. HTTP request sampler. Add an HTTP request under the thread group. Set the server name, path, and method, example get or post, to define the endpoint you want to test. Listeners. Add listeners, like view results tree, summary report, or graph results, to capture and analyze test data. Run the test. Click the Start button to run the test. Analyze the results from the listeners to evaluate response times, throughput, and error rates. Example of basic load test in JMeter script, JMX. Below is a brief outline of a JMeter script for a basic load test. Test plan GUI class equals test plan GUI test class equals test plan test name equals basic load test enabled equals true. Hash tree. Thread group GUI class equals thread group GUI test class equals thread group test name equals thread group enabled equals true. String prop name equals thread group dot number underscore threads 10 slash string prop dash number of users dash. String prop name equals thread group dot ramp underscore time 5 slash string prop dash ramp up period in seconds dash. String prop name equals thread group dot duration slash string prop. Bool prop name equals thread group dot scheduler false slash bool prop. Element prop name equals thread group dot main underscore controller element type equals loop controller GUI class equals loop control panel test class equals loop controller test name equals loop controller enabled equals true. Int prop name equals loop controller dot loops 1 slash int prop dash number of iterations dash slash element prop slash thread group. Hash tree. HTTP sampler proxy GUI class equals HTTP test sample GUI test class equals HTTP sampler proxy test name equals HTTP request enabled equals true. String prop name equals http sampler.domain example.com slash string prop dash server domain dash. String prop name equals http sampler.path slash string prop dash API or page path dash. String prop name equals http sampler.method get slash string prop. Bool prop name equals http sampler.follow underscore redirects true slash bool prop slash http sampler proxy. Hash tree slash. Result collector GUI class equals view results full visualizer test class equals result collector test name equals view results tree enabled equals true slash. Hash tree slash. Slash hash tree. Slash hash tree. Slash test plan. Explanation. Thread group simulates 10 users ramping up over 5 seconds with each executing the request once. HTTP request defines the request to a specific server and path using a GET method. Results listener captures and displays results to analyze performance data. This setup tests basic load handling and is easily scalable to include more complex scenarios with multiple requests, user paths, or integrations.